Here is something that you will all find very interesting. Scott's granddaughter comes along with this book. Like, in other words, instead of going 26,000 miles an hour to get to the moon, you're only going 2,000 miles an hour. We're going to let Scott explain this.
This is the book, and my granddaughter, she's 7 years old, and she comes up and shows me this book that she's looking at. In the front of the book, so I was just showing her a few different things, that they have an image of a communication dish here. That's the space shuttle. Yep. Right? This is Orion's belt. This is Voyager 1. This is the Apollo lander and the CSM. And then they have a little image of one sitting on top of the moon here as well. And then I told her that this is the spacesuit that they use for the ISS, and, you know, the Big Dipper's here and all this stuff. So we were flipping through the book, and we get in a couple of pages. And it was just on astronauts landing on the moon kind of thing. And it says the moon is 238,900 miles away, and it took them 3 days to get there, and they were traveling at 2,000 miles an hour.
Well, actually, that is correct when they reached the neutral point.
Right, but it said they were traveling at 2,000 miles an hour. So let's give the fact that 72 hours, and it was just a little over 3 days, I think they got there. So let's just make it 75 hours times 2,000. You've gone 150,000 miles. But the moon is 238,900 miles away.
Correct.
So if they were traveling 2,000 miles an hour, they're only just a little better than halfway there. And I'm looking in the book and I'm going, but this is an educational book for children. They can't be that far off on their information. Like, that's basic mathematics, but they're sitting in there. And it was just incredible on this particular book with that kind of information, and they really don't care what they put in there for information. That was my point.
Yeah, that's a good point, actually.
Because to travel there, you'd be about 3,700 miles an hour average speed to get there, starting off at 25,700 miles an hour, slowing down to the L zone, right? The Lagrange zone, where the gravitational pull is equal between the Earth and the moon, and then accelerating back up to the 6,000 miles an hour. At 60 miles off the surface of the moon, at 6,000 miles an hour, it's a 1 hour orbit. And of course, when you start looking at the data today, it's changed everywhere. How long it takes them to go around. Now it's an hour and a half. Now it takes 6 days to get to the moon. Well, they worked out in the 1960s what the most fuel efficient method is to get to the moon. That you're going to coast the entire way, that you don't need to adjust your speed to get into orbit, just maybe a little directional to get you into orbit, but not adjusting your speed. All of that was for fuel efficiency calculated out there. Those numbers can't be changed.
Yeah, that's true.
Because you're not going to reach the orbit at the correct speed. That's based on pure coasting. All these other figures out there, and I mean, all these exotic elliptical orbits and everything else, well, it's going to take a hell of a lot longer than that, because how many times are you going to have to use that slingshot effect to get out there? If in fact it even works. I mean, there's a 28-page mathematical calculation on it. I can't think of the guy's name. I think his name is Stuckey or something like that. He won a Pulitzer Prize for it. And they're now all using those figures now. And of course, you have to take into account that gravity is no longer a force and all of that stuff, right? That's where Curious Droid and all the other ones and Physics Girl and that were doing those calculations. There's no mass, there's no kinetic energy, gravity isn't a force. You just get into space and all of a sudden you're just floating there. And if you just go push it this way with a little bit of force, it just all of a sudden keeps accelerating. Completely ridiculous. Nothing to do with physics, all to do with fantasy.
Or imagination.
But that book, I mean, these are educational DK books, right? Or for children and stuff like that, and different age groups that they have in there. And I mean, there should be some consideration of the fact that you're putting at least very simple facts in the book. And my point is that it's straight mathematical calculation. 3 days at 2,000 miles an hour doesn't get you to the moon. And it gives all the numbers are there for the children. It should be at least somewhat accurate.
Well, you'd think they'd fact check it at least.
That was my point. So when a little thing like that in the book isn't there, what about the rest of the books? What about all of the other information they're putting out there? It's nice to encourage people and using books like that have lots of pictures and everything else in them to trigger their imagination, to keep their interest in the subject. I mean, that's all very well done in the book, but the information needs to be at least somewhat accurate. I mean, they just can't put in the book, we did not go there. We cannot go there, because there wouldn't be a whole lot of interest left, would there? I mean, these companies are out there, they're just corporations. They like to make money. And if they get somebody that has a creative mind and can produce a book like that and a whole series of them and have people working on different subjects to produce those books for them, I mean, that's all fine and dandy. But yeah, you're right. Somebody needs to fact check it.
I mean, they got Dr. Sanlin Buxner, author, Dr. Pamela Gay, author, Dr. Georgiana Kramer, author. Well, these are all university graduate people. Why don't they get things right? The Moon, Discover the Mysteries of Earth's Closest Neighbor. Hardcover, 3rd of November 2022. Yeah, you'd think they'd get some fact check done on that, but somebody who knows what they're doing. It's interesting. Many years ago, I was invited to produce a short article about the face on Mars for these people. So I did a 500-word essay on the face on Mars, which they accepted. It's in some book somewhere. I don't know where it is. I've never seen the final result. It's as if they decided to do a book on the moon and just got a few prominent scientists to contribute to it, but they didn't get a prominent scientist to fact check it. It's got 80% 5-star reviews. Oh, wonderful. Dr. Pamela Gay is my favorite science communicator. Kids loved it. Highly recommended. It's one of the reviews, 5-star.
Like I said, there's all kinds of resources out there for people, but if it's not accurate information.
Yeah, exactly. Should be at least accurate.
Yes, and you realize that these are educated people that are putting these to do. They put a doctor in front of their name. So they've got a degree in something, and then that's supposed to mean something in this day and age. I don't know why. It says this is a fascinating guide for 7 to 9-year-olds. So that's grade 2, 3, and 4. In the US, I guess that's a SAT qualification for university.
Yeah.
Yeah. It says the entire subject of the moon, including its formation, geography, lunar phases, a history of NASA's Apollo missions.
Wow.
And the effect on tides on the Earth and nocturnal animals.
Yeah.
So you're going to tell us all about how the moon affects nocturnal animals as well in this book.
And there's a brief bio about the author. Dr. Pamela Gay is an astronomer, podcaster, and writer, best known as the co-host of the astronomy podcast Astronomy Cast, and for her Citizens Science Astronomy Project. She is a senior scientist at PSI, I don't know what that is, and has also appeared on various US television documentaries. Presumably PSI is Planetary Science Institute, I don't know. But this is writing for children, young readers aged 7 to 9. Well, it's good to produce books for children, but get it right, guys. Fact check what you're saying.
She's a graduate of the University of Austin.
Well, that's okay. One of the other authors has worked there since 1996, conducting curriculum development, teacher workshops, and summer camps. She also teaches science and research methodology courses at the University of Arizona. Well, they're well connected with NASA, the University of Arizona. That's quite near Flagstaff, isn't it?
Yep.
So she's probably been out to see Cinder Lake and Sea of Tranquility. Well, you'd hope she would have, because that's part of the whole science project.
Well, she wasn't invited to try on one of their new spacesuits.
No.
They're very dedicated to the work that they do, and they follow whatever the media is putting out there, whatever the other educators are putting out there. They're following along in their footsteps and producing their own unique little venue for themselves. I mean, there's nothing wrong with that. But if you graduated from a university in Texas, you'd think you'd be able to do simple mathematics. Look at that in the book on an illustration and say, hey, that's not quite accurate enough for even third graders. You know, if you want to get down and be exactly accurate as to how far the moon is away, how fast it's traveling and everything else, and do the full calculations on how long it's going to take you to get there. Because, of course, when you take off, you just don't point it at the moon because it's moving.
You find it where it's going to be in 3 days' time.
That's right. Or now it could be 6 days. Or maybe they just wait for it to come around again.
Oh, I think it's at least a month now, isn't it? Last time I saw they were going on the scenic route.
Yes, it's 6.5 days to get there. No fuel on board, doesn't matter, don't need it. You can do anything you want out there. You can speed up, slow down. You can escape Earth's gravity without any fuel whatsoever. Because once you get to space, then mass is a zero number. You just zero it off.
Oh, don't forget the Earth's coming up to meet you.
Oh, yes, it's coming.
Yeah, and by the way, if you're orbiting the moon and you're falling, the moon's coming up to meet you. And if you're on Mars and you're orbiting Mars and you're falling, then Mars is coming up to meet you.
Well, that's because these objects warp the space-time continuum around you.
The space-time continuum in the fabric of space, it's being warped. So if it's being warped and you put the little steely inside of that cloth circle and you spin it around and it goes around and round and round, and eventually it will go down the center of the hole, and that's the end of the little steely. It falls through the hole. So here you have the moon and the Earth, and the Earth is on the outside and the moon's on the inside, kind of. And the moon's going around and it's, going around the Earth, and the Earth is going around the outside of the container, and so is the whole solar system and the galaxy and everything else. It's rotating around somewhere in there as well. Well, here's the funny thing I don't understand. If that's true, then why, when you take that little steely and represent the moon going around the Earth, why does the steely always fall into the hole? Why doesn't the moon then fall into the Earth? And why doesn't the Earth and the moon fall into the sun? And why doesn't all the rest of the planets fall into the sun, if that is how it really works? What's preventing that steely that the guy throws around and it goes around and around? The steely's warping space, but it always falls down the hole. That can't be right. So that means that there has to be a force outside exerting a force on that steely to keep it dead center in its orbit around there, because if it's warped, it's going to fall right through the hole.
Well, here's the other problem with that, because everything is warping the fabric of space. That means everything is traveling in a straight line, and the fabric of space is warping around it. So if that's the case, if it applies to a spacecraft and a person in the spacecraft and everything else, and that's why they're floating together, because they're basically traveling in a straight line and everything else is warping around them. So, given the fact that light travels in a straight line, then there would be no nighttime, because the light is going to follow the fabric of space-time around, and it's going to light up the other side of the planet. Simple as that. Because light has no mass, and they're claiming everything else behaves like light does in space, because they just take mass and just take it right off of there. Of course, any object in space wouldn't be able to impact with anything else, because if it has no mass, it has no kinetic energy, so none could be released. That's another problem. Then, of course, the radiation coming from solar flares, if you follow all of their logic, if the fabric of space is warping around an object like Earth, then it doesn't matter on a solar flare where it's hitting the Earth. It's going to hit all of the Earth together. And when we have brownouts and blackouts and stuff like that, power interruptions from solar flares, which we've had in the last 5-6 months, we've had quite a few, right? Then it wouldn't be affected in one particular area. It doesn't matter what side the Earth is facing the sun. Wouldn't matter, because it's being warped around. It's going to hit everything evenly. So if it's going to have an impact in one area, it's going to impact every area. But that doesn't seem to happen.
Yeah, but the funny thing is, with that little steely that the guy throws inside of that little blue sheet, yeah, he throws it and it goes around and around, but it only can stay there so long before it goes down the middle. So if that is an accurate statement that he's making, then why does that steely fall down in there? That can't be representing planets.
Well, the steely isn't falling down. The Earth is coming up to meet it. And now when you look at it objectively and you realize this demonstration is not a demonstration, because you would have to be I don't want to say the word, floating in space for it to work, because the ball is going down the hole because of the effect of Earth's gravitational pull, which is a force, which they say it's not a force.
It would be nice if he mentioned that, though, but they don't mention that.
No, but that steel ball, to demonstrate the force, just take a 1 pound steel ball and drop it on your foot. You'll see if there's a force or not. Okay? Because if there isn't, then there should be no effect on your foot. And by the way, your foot is coming up to meet the ball. That's how soccer was invented, by the way.
Oh, no. It's the other way around, Scott. The ball's coming up to meet your foot because the ball's the earth, and the earth comes up to meet you when you fall. If he's standing there just before he kicks, the second his foot touches that ball, now the ball's coming up to meet him. That's the same logic.
Well, actually, when they kick the ball, as the ball is coming back down to the earth, as the earth is coming up to meet the ball. That's going to be quite the little earthquake going on there, isn't it? Playing a soccer game. All these theories just have to go away. I don't know why these people wish to come up with all of these new ideas on what's happening in space, because they haven't resolved the first theories to start with. But to come up and just make blatant statements, and they're going to create mathematical equations to prove their theories. I mean, you might as well change the colors of the rainbow and make new names up for them.
And then that book you were holding up, Marcus, now what was that one called?
Owner's Workshop Manual.
It's produced by a company called Haynes, who originally produced a lot of workshop manuals for people to repair their cars. It's very good, very popular they were. Same company that produced the workshop manual for the Apollo 11, 13, 17, all the spacecraft, the space shuttle, space satellites, the spy satellites. This particular one is written by David Harland, who's quite a well-known science writer.
Well, that's quite interesting, because if you own a moon, you need to have the owner's manual.
Of course.
Now you know how to repair it.
Well, doesn't the United States own the moon?
There's got to be a section in that book to keep your moon, I'll say it again, floating.
How to keep the moon from falling down that little hole.
Yes. Marcus, tell us what is in that book. What are they talking about in that book?
Yeah, there are a lot of pictures, photographs inside it showing landing sites, which you'd expect. We've got robotic orbiters and landers. They discuss the lunar orbiter, Apollo candidate landing sites. See what they say about that.
They should have Buzz Aldrin in the door frame and explain how he can be there with that console in the way. That's a good one.
Exactly, yeah.
Well, from what you're showing us here, that's a long ways from what I remember a Haynes repair manual to be.
This is a publicity thing for NASA. See if I can find any pictures. There's some Apollo 11 pictures, but none in the doorway. Now they're going to find water.
Basically, the information in there is if you went to one of the Apollo museums, you'd be getting the same information on the display. So put that in book format with nice color pictures.
Nice color pictures, yeah. Find all that water on the moon. Well, they say they found it.
Well, I'd like to know where the fuse panel is on the moon. Who changes the bulb on the moon? That's what I want to know.
Inside that book,
yeah.
Do they explain what happens? Like, for example, what I would like to know is, here I have my vacuum chamber. I put my little glass of water in there, and I put the large pump on it. I throw the switch, and I come back in 10 seconds, and the water's gone.
Oh.
Now, how come when you go on the moon and you release water, or it just evaporates and it's gone, but yet it's supposed to be laying inside the sides of craters?
They haven't explained that because they don't address vacuum. Certainly the list of working on the lunar surface, seismometers, sampling the Imbrium Basin rim, seeking recent volcanism, sniffing for volcanic gases, lunar heat engine, Soviet rovers, the origin of the moon. Nothing to do with vacuum. Nothing at all. The word isn't mentioned. I know, I expect it to be a standard issue recounting of NASA's story of landing man on the moon. There's another book I got here, Rebecca Boyle, Our Moon, A Human History. Timely. It makes the moon feel closer than ever. New York Times.
When you mentioned Chris Hadfield, him making the statement, I learned more about the moon by reading this book, more than a lifetime of study. But the next comment under that, superb, as much a feat of imagination as a work of globetrotting. Feat of imagination.
Yep, feat of imagination.
Okay, so he learned more by a feat of imagination than he did by any amount of study. That's how I read this. Like I keep saying, all of these things are to trigger people's imagination. It's so easily done. And because it's an intangible thing, if you can't reach out and touch something, you can only imagine it. So then anybody can describe it to you. And that's that feat of imagination that we're talking about. So the author has written this particular book in a method that has triggered Chris Hadfield's imagination. But he's actually saying he's learning something from that.
Well,
more than any other work that he's done. Unbelievable. My hat's off to Rebecca for convincing Mr. Hadfield.
that's nice. That kind of you.
Yes, well, we must bow to the omnipresence of the greatness of Mr. Hadfield. I mean, people make money, like if you're selling children's books, if you're selling whatever, if you're a comedian, it doesn't matter. You're an entertainer of some sort.
Yeah, that's right.
And what are we faced with all the time? Neil deGrasse Tyson, right? He's an entertainer. Cox was doing his documentary stuff, and
yes.
I don't know if he was looking in the lens or trying to make love to the camera. I have no idea when he was talking. It's difficult to watch anyway, just on that basis alone.
Yep.
But they're entertainers. They don't provide any accurate information in any way, shape, or form, nor do they need to. And even if they do make a statement, they don't have to justify it because you can't prove it otherwise.
Yeah, you can't.
It's millions of miles in space. They can talk about anything that's going on. That's why Voyager, they can say, it did this. It just sent us back this signal. It just found this for us. It's just to trigger the imagination.
Well, you know what the imagination's going to say next. Well, at least in NASA's imagination, they're going to have this big headline in the Washington Post that's going to say, new evidence found. Voyager 2 has been found to reproduce. We've just found Voyager 3 out there. It just had a child.
And then Haynes can write an operator's manual on how to deal with the new Voyager Junior. It'll be Voyager Junior. How to change its diapers in space.
Dear, diapers in space, yeah.
Talking about diapers in space, when you go back through the journal, all the transcripts of Apollo, everything else, these people are sitting in diapers. And if you want to sit in a soaked diaper 3 days traveling to the moon, let's say you're going to change that diaper at least 3 times a day, just minimum, just so you don't have, a rash. And let's say that they gave them a little colon blow so that they're pretty good on the number 2 end for a little bit, so they can go 2 or 3 days. Let's say 3 days. They get to the moon, they don't have to do anything serious that way. So they're just dealing with urine. But they're in these diapers. They got to change them. And we know how the diapers work. They know that they were actually physically taped onto their bodies. Of course, they rolled them up and kept them and brought them back so they could be studied. So you make it to the moon, and it's a fairly simple process because you're just dealing with urine. But after that point, they're out there for 12 days. And there's 3 guys. That's one hell of a pile of diapers, isn't it? Where are they stored on that machine? They have those little bags on the containers on the wall.
Yeah.
And they're yay big. You're going to have at least 20 diapers per person. That won't get you through, will it? You need 3-day average for 12 days times 3 people. Well, there's a gross of diapers right there, isn't it? Where the hell are they? Not to mention the fact that you're keeping them to bring them back. I mean, you can't just open the window and throw them out. This isn't an RV trip. We're not going camping for the weekend. You can't put them on the campfire and burn them. Where the hell are they? They claim they brought them back, for their biological experiments or whatever the hell they want to do with them, to see how the body reacts over time in space in zero gravity. They want to see the reaction and what chemicals are, I guess, in the fluids that they are expelling. But where the hell are they? And not only that, You're going to hear about this in their conversation. Anyway, I just thought I'd bring that stuff up on the diapers because if you really stop and think about the reality of 3 people traveling for 12 days in that kind of a confined space, we have biological functions that must go on. Like they are essential. You can't stop them, and it's not recorded. You look at the transcripts, it's not recorded there anywhere. And the only way 3 guys are going to be able to pull that off, they're going to be making jokes about it. There's absolutely no way you could not clean somebody's backside off and clean them up and put a diaper and tape them back on there. There's absolutely no way that they could omit that in the transcripts, because it's going to happen at the end of an EVA. It's going to happen before an EVA, before they get ready to go out, whatever. It's going to happen. They can't say that, we gave them a diet so that they don't have these problems, right? Because that's not going to happen either. But it's not in the transcripts. And NASA has got to rewrite these transcripts so that they are accurate as to what real life situations would actually be.
Here's a quote. How often do astronauts have to change their diapers? On average, astronauts have to change their diapers every 3 to 4 hours. This means that they have to do it about 8 to 12 times a day.
I just thought, just for the fun of it, that I would ask ChatGPT something interesting. Okay. Because we know that the astronauts were smokers, and they were regular smokers, some of them heavier smokers than others. So for anybody who has smoked, myself included, we all know what happens if you go a day without a cigarette. You will just about go crazy. So I asked ChatGPT if the Apollo astronauts took any nicotine substitutes with them while they were in that capsule for those 7 days. And this is what it said. No, the Apollo astronauts did not take nicotine substitutes with them. Smoking was strictly prohibited on spacecraft due to fire hazards and the need to maintain a clean, oxygen-rich environment. Oh my God. No reported need for nicotine substitutes was the final answer here. Can you believe this? No, that's impossible. They'd go crazy.
I'm going to pull a picture up of the clean room, and there's cigarette butts on the floor in the clean room.
Look at it from a medical point of view. There's no cotton picking way that those guys could be sitting inside of that command module. You're going without a cigarette for an entire week. Well, if that's a clean room, what are all those cigarette butts doing in there?
Well, that's the same clean room where the screws on the camera got rusty. On the magazines, that's where they got rusty on there, and that's where the mold was growing on the experimental equipment. That's the same clean room where these cigarette butts are. And no, they didn't have a problem with cigarette withdrawal, nicotine withdrawal. Why would they? They're Apollo astronauts. They can do anything. They can even go to the moon.
They got the right stuff.
The right stuff.
Yes.
That's the right stuff that's coming out of their diapers.
Where do the diapers get stored inside that lander? I mean, Apollo 17 was on the lunar surface for 72 hours.
Yeah, you'd think they'd be laying on the ground outside when they got out on an EVA.
Yeah, you would think so, wouldn't you?
Because their refuge bag is already full when they get there. Every time. It's already full. Before they step out, it's already there.
This is another problem, because I just asked ChatGPT a question. Now I said, can a person go without a cigarette for 7 days? What would the symptoms be? And this is what it said. Yes, a person could go without a cigarette for 7 days, though it may be difficult depending on their level of nicotine dependence. Withdrawal symptoms such as irritability, cravings, anxiety, difficulty concentrating, and trouble sleeping typically peak within the first few days and gradually subside over time. For heavy smokers, the first 72 hours are usually the hardest, as this is when the body is adjusting to the absence of nicotine. However, after a week, many physical withdrawal symptoms begin to lessen, and it becomes more of a psychological challenge. These guys need to concentrate, don't they? They're taking star shots. They're taking navigation readings. They're punching in numbers into that computer. My goodness, how can you concentrate if you're a smoker, just a regular smoker? We're not talking heavy smoker here. This is just the average person.
Yeah, there's that film you show quite often, Robert, of an astronaut in a spacesuit smoking. I mean, you could see it. Obviously they need their cigarettes.
So how did they go 7 days without a cigarette?
Probably they didn't, because they would know how effective that would be. If they stopped smoking, the effect of that would compromise their ability to drive this spaceship.
They wouldn't be in top physical or mental condition. It's like any other distraction, and a physical distraction to the body. You won't be able to concentrate on anything.
You're withdrawing.
It's no different if you need to go for a pee really badly. You can't concentrate on anything for very long because you need to go. That nicotine withdrawal would be the same.
And yet we're supposed to believe that these guys went a whole week without one single cigarette, a puff or anything. I found this interesting too. I asked to ChatGPT, did the Apollo astronauts go without smoking while traveling to the moon? And ChatGPT says, yes, the Apollo astronauts went without smoking while traveling to the moon. Smoking was strictly prohibited on spacecraft due to the risks it posed in a pure oxygen environment, which was highly flammable. Additionally, the spacecraft had limited ventilation, making smoke and odors a serious issue. None of the Apollo astronauts smoked during their missions, and there is no record of them bringing any nicotine substitutes either. While some of the astronauts, like Apollo 12's Pete Conrad, were known to be smokers on Earth, they had to abstain for the entire mission duration, which lasted about 8 to 12 days, depending on the mission. Oh, that's impossible.
Keep that line. The smoke and odors were a serious problem, because we need to discuss that odor problem that they're going to have. 12 days without any hygienic facilities out there.